Hello students, today I am going to discuss about the new topic which is work energy and power. Work energy and power is very important. It is basically used in daily life. Now see, what is the meaning of work energy and power? First you see energy, work energy and power. Work, energy and power. This is the name of the chapter. First you see what is the meaning of work. So first, suppose this is a kind of object. If we consider this is a kind of object, so when a force is acting on the object, what will happen? Due to the force, the object will shift from one place to another place. Suppose the body is shifting from one place to another place. So initial position at A, now final position at B. So in this case here you can see displacement is here. Therefore work done will be F into X. So you remember work done means, you remember when force is acting on a body and due to the force the body is displacing. You can see when the force is applied on the body displaces from one place to another place. There is a displacement. Then we can say work done. So basically work done is represented by W is equal to F dot X. So in this case we can write Fx cos theta. So here you can see this is a scalar quantity. So work done is equal to Fx cos theta. So here you remember everyone. So W means work done. W means work done, and F is a force. F is a force, and X displacement, and theta angle between F and X, So in this case you remember when we are talking about the work done at the time, you remember work done is equal to force into displacement. That means when force is acting on the body and due to the force the body displaces from one place to another place, then we can say this is a work done. So there is some condition in case of work done, you remember. So what are the conditions? Suppose I have given the formula W is equal to Fx cos theta. Now see, F is a force, X is the displacement and theta is the angle between F and X. Now see, there is some conditions. Condition, that means case number 1, we can say case number 1, when theta is equal to 0, when theta is equal to 0, we can write W is equal to Fx cos 0. W is equal to Fx cos 0. That means it is Fx, that means cos 0 means 1. The value of cos 0 means 1. That is why we can write W is equal to Fx. So we can write this is a maximum work done. That means work done is maximum. Case number 2. Here you can see case number 2. We can write here W is equal to when we can write when theta is equal to pi by 2. At the time we can write W is equal to Fx cos pi by 2. Cos pi by 2 means it is 0. So it is 0. So it will be ultimately we can write 0. Work done is equal to 0. So when angle between the force and displacement is 90 degree, then work done will be 0. Therefore W is equal to 0. Case number 3, when we are talking about the angle, that case number 3, when theta is equal to pi, at the time we can write W is equal to Fx cos pi, that means minus Fx, that is force is minimum, minus Fx means force is minimum. So basically we are getting the 3 conditions. In case of work, you remember W is equal to Fx cos theta. This is the normal formula, and from this given formula we can write 3 conditions: case number 1, case number 2, case number 3. So in case number 1, you can see when theta is equal to 0, we can say W is equal to Fx. Fx means work done is maximum, and when we are talking about the theta is equal to pi by 2, then work done will be 0. This is minimum, that means very 0 means very near close to the 0 value. So here case number 3 we can write when theta is equal to pi, that means cos pi means negative value minus 1. So work done will be here minus Fx. So this is the idea about the work done. You remember, so what is the unit of work? basically unit of work is joule. SI unit is joule and CGS unit is erg. So work basically expressed in terms of W. Work is basically expressed in terms of W, and there is a three condition. One is maximum work, one is zero work, and other is minimum work. So maximum work done, zero work done, and minimum work done. So next you can see how this work is applicable in case of numericals. I will discuss. First I give the theory part of this chapter. So this is the work done. So now see, basically this work done we can also express in terms of differentiation as well as integrations. So first you see work done by variable force, by variable force. Work done by variable force. So work done by variable force, you remember. So what is the work done by variable force? So in this case you always remember when you are talking about the work done by variable force in terms of displacement, in terms of displacement, so you remember is equal to F into F dx, here x1 and x2. So dear students, you always remember work done can be expressed in terms of dot product also, in terms of like this also. That is why this work done, it is called work done by variable force in terms of displacement. Similarly, you can see work done by variable force, work done by variable force, work done by variable force in terms of time, Now see, in this case, the earlier case it is given here displacement, that is why I have written lower limit x1, upper limit x2, and similarly in case of work done by variable force in terms of time, it is given like this. Integration, we can write here integration m dx by dt into d square x by dt into dt. This is the formula, and here this time will be, suppose here t1 and here t2. This is the formula for work done by variable force in terms of time. So you remember, normally we are getting three types of formula in case of work done. One is w is equal to f dot x, and second number w is equal to f integration f dx, x1 lower limit x1 and upper limit x2. And in case of third number, work done by variable force in terms of time, we can write w is equal to m dx dt, d square x dt square dt. Okay, so three types of formula we are basically used for the numericals in case of work done. Now you can see this is the formula for work done. Next you can see energy. What is the meaning of energy? Energy means ability to do the work. Ability to do the work is called energy, and energy basically it is energy basically there are different types of energy, but in this case you remember only potential energy and kinetic energy. So you remember definition of energy is ability to do the work is called energy, and this energy can be expressed in terms of joule. So you remember energy basically two types. One is potential energy, and another is kinetic energy. Kinetic energy. One is potential energy and other is kinetic energy. In case of potential energy, you remember when the body at rest position, energy possessed by the body when the body at rest position, then it is called potential energy, and energy possessed by the body when the body is in motion, then it is called kinetic energy. So in case of potential energy, formula is mgh, and in case of kinetic energy, you remember work done is equal to half into mv square. This is the formula, and sometimes this kinetic energy also expressed in terms of E, w is equal to half m v square b square. So W is equal to mgh, this is the potential energy, and E is equal to half mv square, this is the kinetic energy. So you remember this is an important formula for solving the numericals problem. Now one more things, next you see here mass I have used, mass of the object. When the mass of the a body of mass m is placed at a height h, then the potential energy will be W is equal to mgh. On the other hand, here W is equal to half mv square, that means E is equal to half mv square. This is the kinetic energy. That means when the body is moving, at the time the energy produced by the body is kinetic energy. So next you can see relation between kinetic energy and momentum, how the kinetic energy is related with the momentum. So momentum already I have discussed earlier. You remember momentum means the product of mass and velocity of a body. So this is called momentum. So momentum basically it is represented by mv. So how this momentum is kinetic related with the kinetic energy? So relation between kinetic energy and momentum. Kinetic energy and momentum. Okay, so relation between kinetic energy and momentum. So you remember, so normally we know that the kinetic energy is, suppose we consider Ek is equal to half mv square. So this can be written as like this, mv square v square, so divided by m. So we can write half here p square divided by m. So p is equal to under root twice m key. So this is the a kind of formula related with the kinetic energy and momentum. So you remember, when we are talking about the momentum basically expressed in terms of mass and velocity, and how this momentum is related to the kinetic energy. This is the formula, P is equal to under root twice m Ek. So here P means momentum. You remember, P means momentum, and here K is a kinetic energy. K is kinetic energy, and m mass, here m mass of the substance, mass of the substance. So in this way, you remember, you have to memorize, you have to remember about the physical significance of all the variables which is mentioned in the given formula. So now this is the relation between kinetic energy and momentum. Next you see power. So power means rate of change of work done. So P is equal to W by T. Here P means power is equal to rate of change of work done. We can write here. You remember, students, the physical significance of the all terms is very important. So P means power. Power basically it is expressed in terms of what? And here W means work done. Work done basically represented by joule, and here time is time. This is called time. That means second. Second. It is represent time. Time means second. So in this case, you remember P means power and work done. W is equal to W means work done. So in case of work done, we can consider anything. That means it may be in terms of kinetic energy, it may be potential energy. So this formula we can also write like this: P is equal to half mv square by T. This formula we can write like this, or P is equal to mgh divided by T. So this is also a kind of formula. So power can be expressed in terms of work done, in terms of kinetic energy, in terms of potential energy. I think so all the physical significance already you know. Next you can see relation between power and velocity. Relation between power and velocity. So power and velocity. When we are talking about the power and velocity, you remember power basically it is represented by W by T. Work done, force into displacement divided by time. So here F into X by T is equal to F into V. So power is equal to F into V. So this is the relation between the power and velocity, power and velocity, power and force, or velocity, force, or power. This is the relations you remember. Here you remember power, and here force, and here it is velocity. So you remember, for the solving of numericals problem, you must know P means what is the meaning of P. Sometimes P also it is represent momentum, sometimes it is also represent power. So you have to check whose unit is given, whether it is kg meter per second is given or watt is given. If watt is given, then you have to consider power. If kg meter per second is given, then you have to consider momentum. So this is the idea about the work, energy and power. So dear students, the numericals of the chapter is very important. You must know all the things, how we can solve the numericals problem. So I revise this formula. So basically in this chapter we have to do different types of numericals. There are different types of numericals will be given to you and you have to solve using this formula. So for example, so I have given quick revision. So you remember the first formula I have given, W is equal to force into displacement. So using force into displacement, what is the numericals? Suppose you have given, there is a question, one question is given. Suppose if F is equal to, suppose 2 I cap plus 3 J cap plus K cap, that means this is a force, Newton force acting on a body, okay. So if F is equal to 2 I cap plus 3 J cap plus K cap, Newton force acting on a body, and displacement of the body due to force is, suppose here distance it is given, suppose I cap plus 3 J cap meter. So find the work done. What is the work done? Find the work done, or find the work done. So we have to calculate the value of W. So normally you remember solution. In this case you can see here force is given. F is equal to twice I cap plus 3 J cap plus K cap. So here F is equal to 2 I cap plus 3 J cap plus K cap. So and here D is equal to I cap minus J cap plus 4 K cap, like this. So in this case we have to calculate the value of W. W we have to calculate. So you can see W is equal to question mark. So in this case W is equal to force into displacement. We can write like this. This is the formula. So instead of X we can use here D. So direct formula we can write twice I cap plus 3 J cap plus K cap, and here you can see I cap minus J cap plus 4 K cap. So in this case you can see already I discussed in the previous class that how to solve the dot product. So first coefficient of first term multiply with the coefficient of first term, say coefficient of J, coefficient of K, in shortcut formula. So you remember 2 into 1 it will be 2, plus minus it will be minus, 3 into 1 3, plus 1 into 4 it will be 4, it will be 3. So it will be the 3 will be the joule. So W is equal to 3 joule. So W is equal to 3 joule is the work done. So when a force is acting on the body, twice I cap plus 3 J cap plus K cap, and due to this force when the body displays I cap minus J cap plus 4 K cap, then we can write the work done will be F dot D, that means according to dot product, we can easily solve the numericals. So this is the answer. So work done will be 3 joule. Now another questions you can see how we can use in terms of displacement and in terms of time we can easily calculate the work done. So basically you can see here, suppose one question is given related to this. When a force, that means if force and displacement is related like this, F is equal to x square plus 2x plus 3 Newton. That means force and displacement is related, F is equal to x square plus 2x plus 3 Newton. Find the work done. We have to calculate the work done. That means find the work done for the here given. You see displacement is given. So find the work done from 0 to 5 or 0 to 1 meters. So we have to calculate the work done from 0 to 1 meter. So in this case you can see if force and displacement is related, F is equal to x square plus 2x plus 3, that means the force and displacement it is given to you. F is equal to x square plus 2x plus 3 is given to you. So find the work done from 0 to 1 meter. So we have to calculate the work done from 0 to 1 meter. So basically it is related with the integration formula. So how we will do? So already we know W is equal to, this is the formula, F dx, and here x1 and here x2. So according to our question here given, you can see x1 means it is 0, x2 means it is 1. Now the value of x is x square plus 2x plus 3 Newton. Here Newton no need to mention, but here dx is given, so you have to mention dx. So in this case you always remember, so after integration, so in physics I told you that in previous class also that the integration and differentiation is very important. So that is why you should know about the basics of the integration, how to solve. So I will write directly, that means what is the answer for that, how we can do this integration part. So integration, after removing the integrations, we can write like this, x3 by 3 plus 2x square by 2 plus 3x. So after integration you will get this result, that means like this you will get in this way. So here 0 and 1. Okay, so now you can see the 1 is the upper limit and 0 is a lower limit. So that is why we can write, instead of x we can write 1 cube by 3 plus 2 cancel, so 1 square plus 3 into 1, and here minus 0 cube by 3 plus 0 square plus 3 into 0, we can write like this. So 1 by 3 plus 1 plus 3, and it will be 0. So 3 plus 1 means 4. So we can write 4. So it will be 13 divided by 3. So this is the joule. So 13 divided by 3, this is the work done for that. So you remember 13 by 3 is the work done for the interval of distance 0 to 1 meter. So in this way you always remember the work done can be calculated in terms of displacement. Here you can see displacement, it is given F dx, so we can write like this. Next you see one more question, it is related with the time period. That means if time is given to you. So question I am giving to you, you just see one more question. You can see if displacement time relation is represented by, if displacement time relation is represented by displacement time relation is represented by x is equal to t to the power half. X is equal to t to the power half. It is given. So find the work done. Find the work done. Find the work done for the time interval. For the time interval. For the time interval. For the time intervals 0 to 1 second. So earlier I have given 0 to 1 meter, but in this case you can see 0 to 1 second. So in this case you can see which formula we are going to use, and you remember the mass, it is given suppose 1 kg to u. So this is the relation. That means if displacement time relation is represented by x is equal to t to the power half, find the work done for the time interval 0 to 1 second. So I have discussed about the work done in terms of dot product. I have discussed in terms of displacement. Now I am going to discuss in terms of time, because here you see time is given, displacement time relation is given, and mass also given. So you just see how to solve. So here simple mass is given here. Mass is given 1 kg. So in this case the solution will be like this. So the displacement relation, it is given x is equal to t to the power half. In this case we have to differentiate, because already we know this formula w is equal to integration m dx by dt d square x dt square into dt. This is the formula. So first dx by dt is equal to, you can see here, so half, it will be t to the power half minus 1, it will be t to the power minus half. So this is the velocity. Now double derivative d square x dt square. In this case again you can see minus half, it will be there, and t to the power minus half minus 1. So it will be minus 1 by 4 t to the power minus 3 by 2. So after 2 time differentiation we are getting minus 1 by 4 t to the power minus 3. Now you can see according to our formula w is equal to integration 0 to 1 second, it is given, m dx by dt it is given, and here d square x by dt square it is given, along with time is given. So in this case you can see according to our question here given mass is given 1 kg. So we can use here mass 1 kg, and dx by dt, the value of dx by dt it is given like this. That means half into t to the power minus half. This is the value of dx by dt, and in case of d square x by dt square, the value it is given minus 1 by 4 t to the power minus 3 by 2. Now here dt. So just from the given relations, at first you have to do first differentiation. After doing the first differentiation you will get the velocity, and second differentiation you will get the acceleration. So in this way, if you check this part, then we can write here. So minus 1 by 4 it will be minus 1 by 8. So here 2 into 4 minus 8. Now t to the power minus half minus 3 by 2, and here dt, and time is given 0 to 1 second, 0 to 1 second. So in this case you can see minus 1 by 8 t to the power integration, here t to the power, what is the value? T to the power, we can take LCM here 2. So minus 1 minus 3, and here dt 0 to 1. So minus 1 by 8, and here we can write minus 1 minus 3 minus 4 divided by 2, it will be minus 2. That means t to the power minus 2, here dt, and 0 to 1. So again come back this side. Here work done w is equal to, you can see minus 1 by 8. In this case here t to the power minus 2, that means t to the power minus 2 plus 1 according to integration rule, minus 2 plus 1, and here the upper limit 1 and lower limit 0. So in this case minus 1 by 8, and here we can write minus 1 by t. So it will be 1 and it will be 0. So in this case minus 1 by 8. So and minus minus it will be plus 1 by 8. So here 1 by 1 and here 1 by 0. So upper limit and lower limit you have to put. So I think you have idea about the basic idea of algebra. 0 by 1 means it is 0, 1 by 0 means infinity, 1 by infinity means 0. So in this case I have considered 0 to 1, that is why 1 by 0 it will come infinity. But sometimes you remember instead of if you consider limit 1 to 2 or 1 to 3, 1 to 4 like this, so this term will not come. So in this case 1 by 8 and here 1 minus 1 by 0 means infinity. So work done will be like this. So if it is given limit 0 to 1, then this term is coming like this, and if you consider the different limit, then only you just get the exact value. So this is the work done. So work done in this way we can easily calculate the value of work done which is given in terms of displacement time relation. Thank you.